As the water passes through the vessel, the perchlorate adheres to the resin, and then we backwash. And we use salted water, backwash, right off the resin. We regenerate the resin so the resin is good to go again as it turns. There are 30 vessels on there. Some of the vessels are in chicken mode where it's taking the chlorine off. Some of them are in a backwash mode, backwashing the resin, chlorine off the resin. Some of them are in a rinse mode where it's rinsing it and then it comes back into the front as it turns. So as we're talking, 7,800 gallons per minute is going through this thing all the time constantly. It just comes in, goes out, comes in, goes out, and it turns on the table. It's treating, backwashing, rinsing, coming back in. And it takes 15 hours, anywhere between 15 to 17 hours to make one complete turn on the table. This is ultraviolet lamps. The ultraviolet lamp is housed inside of a glass housing to protect the lamp. So you have the lamp inside the housing. And then you have a rack of these going down in these things here. There might be like 7 or 8, 9 of these lamps in that rack. As the water comes through and passes the lamps, it photolyzes, destroys the 1,4-dioxane and the nitrosamine. The water goes across, falls down inside of another wet well below us. Because we lost pressure coming across there, the boosters pick up the water and repressurize it and send it onto the on-site reservoir. Okay. Sample tap. We take a sample here to make sure that we remove the nitrosamine. After each treatment system, we take an influent concentration to see what's in the water, which is the combo coming in, influent water. We take a sample after the air strippers to make sure that the air stripper is doing what's supposed to be doing, taking out the bulk organics. We take a sample at the ISEC of those tubes coming down the building to make sure that we remove the perchlorate. We take a sample here to assure that we remove the 1,4-dioxane and the NDMA, the nitrosamine. Then the water is picked up, moved to the reservoir. We take a sample of the reservoir to make sure that everything is taken out. Okay? We dial in the concentration of NDMA in the computer sensor, whatever, knows how many racks of glass are supposed to be on at a given time in order to destroy volatilize and chemicals in the water. Okay? Now we're going to go outside, original wells, and this one over here, you see the C on the motor, B6C. Those are the two original wells that provided water to this plant. Originally it was this reservoir, those wells, there was a house. Where this building is sitting over the house system here. And where all of that across, there were 4 houses across there. We have to buy that land, tear down the house, and build this street. That's about 600,000 gallons. That's a small one. Okay, we have 4 off-site wells. We have 2 on-site wells. We're only running half the plant right now. We're doing some maintenance on one of the turntables. So we have 2 off-site wells providing water to the system. It comes through, and you see the green light. They're running. These are off, waiting in standby. These are the alternate wells that are on-site, 4 off-site. Then we're going to go to the air stripper. Okay, we have the 4 air strippers, 1, 2, 3, and 4. 2 are running, 1 is running. The other 3 are off, correct?
2 are running.
2 are running?
1 and 2.
Okay, so tower 1 and 2 are running. Yeah, there's the green. And the other 2 are off right now because we've got half the plant down for maintenance. Okay, and then we're going to go to the next screen. Okay, those are the booster pumps in the wet well. We have 2 boosters picking up the water from the wet well, pushing it into the next system. We have 3 standby. Again, we have redundancy. If we blow a motor on one of the boosters, we still have enough boosters back up to push water through the system. The ISEP, the filters are good. Those are the filters that we showed you. They have the bag filters to remove sand and sediment and fines because we don't want that going into the resin. The ISEP. This is, hey, one of the air strippers is not running, shut down, sending an alarm, check this out, check this out, check this out. So he has to acknowledge it, figure out what's going on, acknowledge, try and put the thing back online. If the turntable jumps or it doesn't move or something's happening with it, the computer senses that, hey, I got a problem over here, check on this, and it does that. Again, redundancy, belt and suspenders, that if one thing fails, it won't let the other system go. Just one of the items, it's all built in. It has set points, and you tell it a high alarm, a low alarm, whatever.